Hey there, this is Seth Waters from Channel 9 coming to you from the beautiful city of Oslo in Norway. We're here for NDC 2017. They let us sneak into their conference to bring you all the good stuff that's happening. They're going to let us stream some of the awesome sessions. You should be able to see what they are. Hopefully, if not, I'll tell you a little bit about them. We have tons of awesome guests as well here. There are amazing speakers here. One of them, Emily Bache. How are you?
I'm very well, thank you.
Did I say it right?
Yes, you did.
Fantastic. So why don't you introduce yourself?
So I'm a software developer. I've been working as a programmer since about 1998. I've been living in Sweden, in Gothenburg, since 2000.
Fantastic.
But I'm originally from the UK.
So you are speaking about microservices. Why don't you tell us a little bit about your talk?
Yeah, so I've got some experience working with microservices. In my previous job, actually, I worked for a company called Pagero, and we had, when I joined them in like 2013, they were just packaging all of their system as microservices in Docker, and they had this application that they've been running for like 10 years, a Java Enterprise application. And the growth in traffic was so big that they couldn't handle it within just this one monolithic application anymore. So they worked out how to package this in Docker and building all new features then in separate microservices, also deployed in Docker.
Right.
So they just went into production with that just after I joined in early 2014. And that was really big change for them.
So tell me about, like, I'm always curious about like moving something from a legacy application over to something that's containerized. Now you don't have to speak specifically about your project, but what was that like? Tell me a little bit about that.
Well, it actually, most of the work was done before I arrived, I have to say, but there was a lot of work just basically trying to package it into a Docker and writing the Docker file and setting up the build script to build the Docker as part of the build, so that when you did the full build, you'd end up with this Docker that you could then deploy on your local machine and test kind of by hand. So that was a big change for that. And then we also, this was quite early days for Docker, so we had to build our own deployment tooling as well.
Oh my goodness.
So one of my colleagues built a whole thing in Scala that can deploy the Docker onto, you write some text files that explain how to set it up, how to connect all the Dockers together and where to put them, which machines they should run on. And these days you'd use something like Kubernetes.
Of course.
But we built our own tool for that as well.
Holy cow. So look, I build a lot of demoware, right? I'm a programmer, but not like a real one like you, that has actually built real stuff. I'm curious, when you came in and started looking at this particular system, what were some of the differences that you'd seen when it came to containerization that maybe you hadn't seen before? Do you get what I'm asking?
Yeah.
I'm trying to understand, like, as a developer, how can I think about these things a little bit better? And you have experience with this. Yeah,
I mean, the thing I noticed that Docker is so fast. You can deploy your whole system. So I got used to deploying like 7 or 8 Dockers on my local machine, and it goes so fast, and then you can get them to interact with each other, and the whole system is running there. And that was a kind of a revelation. I can run an entire system test on my machine because Docker is so lightweight.
I see. So are you deploying like the entire environment onto your machine to do testing? Is it possible to do that every time?
Initially it was. Because of course we had this monolith, so you could deploy that. We'd been able to deploy that on a local machine even before we containerized it. But then we started building microservices for all the new features, and then the number of them just gradually increased. So at first, you would deploy 3 or 4, and then a few months later it would be 5 or 6, 7, and then, we got up to about 15 that you could deploy locally on just one machine and use. And then at some point it just got a little bit too much for one machine. So at that point we had to have some other strategies to not deploy the entire system to be able to still work on one machine. But
so what? Like my curiosity with this is you're primarily focused on the testing of these things. How do you test these things once you can't fit them on your machine anymore?
So of course you just need to not rely only on your own machine. You have to have other test machines that you can get access to. So a lot of people these days will use the cloud so that they can get very elastic, so that they can just use the machines while they're running some tests. we made a strategic decision to own all our own hardware, which might seem a little strange, because in a way it costs more, but in a way it costs less.
Right.
So we bought a server park for our production machines and a smaller one for our staging and testing.
Right.
And or we built the deployment tools that allowed me to deploy my code to them.
And so that's how when you tested, you would go to that staging or testing environment.
Yes, for some of the tests. Others of the tests I could, for when I was testing a particular feature, I might not need all the services. So we had a flexible deployment, we call it a recipe. It's like a bill of materials that's saying I want to deploy all these services. This is a subset of the full system, but this is enough services to just test this feature that I'm working on. So locally I can deploy, 5 or 10 services.
So I'm starting to get a sense of like the complexity of doing this stuff. So if someone's like moving their monolith over to a microservices architecture, clearly they're going to have to test. Were these tests automated? Were they not automated? What are strategies that you suggest for developers like me that want to move over? How do I test these things properly in a rigid, sort of repeatable way?
So that's kind of where I find things really interesting. How do you set up a test strategy? What's the high-level picture of the different kinds of tests you're going to have? Which ones are you going to automate? Who's going to do the testing? Who's going to write the tests? At what point do you run them? So these are all the questions that I was very interested in. So when I came to Pagero, I looked at the test strategy they had, and I found it was actually pretty solid. They had a lot of unit tests for what they were doing already. They had some full system tests already going through the user interface. We have a web interface, it's a cloud system. And they'd spent some time building some tests with Selenium and stuff that would exercise the whole system. And then in between, they also had some, so if you think of the test pyramid, you've got the unit test at the bottom and the GUI test at the top.
Right.
But they had some in-between tests too. They had tests for the data layer, testing the object relational mapping for the monolith. And they had some service tests which were using an API to access whole features. And the API in the monolith was a Java RMI.
Okay.
So I came in, I thought, well, this is actually quite healthy. But it doesn't work with microservices very well. So when you've got a new feature in a microservice, maybe that microservice doesn't have a database even. It doesn't have an ORM layer. And maybe that microservice also doesn't have a GUI, but it has an API. So, and maybe you can't test the whole feature with just one service. So at some level you need to rethink those middle layers primarily, and that was my experience at least of the test pyramids.
So how do you do that? Like I'm trying to understand. Like now that you've gone through, you said, yeah, this is a really healthy testing environment, but you found that as you moved to microservices, it wasn't as good.
It wasn't. We couldn't directly just keep the same strategy.
Right.
Basically, we couldn't. It didn't make sense to continue building these ORM tests for services that didn't have any database.
I see.
But what we do have now, which we didn't have in the monolith, was a very natural API for some parts of the system. A microservice has an API, and you can deploy it independently of the other microservices.
Right.
It might not get much done without being able to talk to the other services, but you can actually deploy it separately. So it's very natural then to have some tests that will, at the microservice level, that are just exercising that one part of the system.
So how do you do that without it having access to the other microservices? Do you spin those up, or do you fake the microservice? How do you do that?
So some of the microservices are kind of very essential infrastructure, like being able to talk to a queue, a rabbit queue, being able to look up basic configuration data in our configuration service. So when we were testing one microservice, quite often we would start some of the very basic infrastructure services that all the services needed. But then you would have the test case try and mock out and respond to all the other calls. So you were trying to isolate it from the rest of the system to some extent, so that you could check that this one service actually was doing what it was supposed to do. And if all the other services responded the way you expected, then it was good.
So you would mock out some of the API calls? Is that happening in the code? Or are you spinning up a fake microservice? How does that work?
So we would we were using RabbitMQ
Okay.
and Protobuf. So
Okay.
each service was talking to the others via Rabbit and sending Protobuf messages.
I see.
So all the test had to do was to listen to the messages coming in on the queue and put its own messages back on the queue to respond to them.
I see. So, okay, so that makes a lot of sense because generally when you're writing these things, you got to make the container not be dependent on other containers except via very specific messaging. Would you say that the only way to make microservice architecture is to use messaging? Is there other things that you would use? Because I'm trying to see, like if two microservices were seriously dependent and you were trying to test just one, you'd have to spin up the other, but you don't want to do that when you're testing.
Yeah, so you do want to see that the parts work together because you've got to unit test to the ultimate, you just one method
Right.
or something, and you do that so that you can be sure that this method does what I think it should do. So it's just kind of similar with a microservice. I want to see that this service does what it's supposed to do.
Okay.
And if I test with the real version of the other microservice, then it can get confusing as to exactly where the problem lies.
Right.
So you want to have a very well-defined API between them. Define which messages they send, what the contents of those messages should be,
Sure.
and the format of the responses that are expected, and whether a response is expected. Some of them are fire and forget.
I see.
So I think it's useful to have a test at that level that doesn't include the other service.
Uh-huh.
Now we didn't do this, but I think it would be very useful because once you've got a mock for that other service that the test has created, that helps me test my service, and that mock effectively defines what the other service should be doing.
I see.
What responses I expect from that other service. So in a way, that mock is a kind of it could be turned into a test for the other service.
Holy cow, that's actually really interesting. How do you do that? Because now you have this interesting boundary of communication between microservices, where for one it's a mock and for other it's a test. How do you reuse that code?
Yeah, so this is the part I didn't actually solve, but I've been thinking about this since, thinking we really should have done that because that would help to really pin down the APIs,
Right.
the semantic. What are they talking about, and how can, if I own this service, how can I say to the other service owner, I need you to respond like this. Here's my mock.
I see.
Do like this.
That would actually be
Yeah.
really interesting.
So I think the name for this is consumer-driven contracts. I've been reading up on this afterwards, and I kind of feel, I should go back and try this.
Yeah,
So
and
that's
so
my latest thing I want to try
If
out.
you were to go back and try that, what would that code look like? I mean, because it's really interesting. Because mock and a test are very different things.
Oh, well, no,
Help
they're
me
not.
out.
No, help you. Okay, so the mock in some sense is just a recording of the traffic.
Right.
So in another context, I've used a tool called Capture Mock that basically you put it listening on a socket, and it just writes to a text file all the traffic that it sees on the socket, both forward and backwards. And then when in record mode, it will just record all the traffic. And then you switch it to replay mode. And then when it receives some traffic, it looks up in the file, okay, I've seen that message before, and after that message, I responded like this.
I see.
So here's the response. So you just replay the canned responses. So the mock is just a recording of traffic at some level.
I see.
And in some sense, a test case is just a recording of this is what the user does, and this is how I expect you to respond. So you can turn it around to test it doing it in the other direction.
So usually when I've done mocks, I've mocked up objects to respond, like when I'm using interfaces, for example, and I want to say, hey, if you're using this interface, use this mock and it will return a certain way. You're using these kind of mocks that you're talking about seem a little bit different than what I've ever heard of, which are really cool. But I'm trying to understand, when it's in record mode, is it just recording all the requests? Do you have to then put all the replies in there?
Yeah, so it's just recording. The messages on the queue are just they're protobuf.
Right.
It's like
JSON
pieces
stuff,
of text, yeah. And you just write them to a file.
And for the response, though, because I know those messages are coming in, if the service is supposed to respond, do you just put the responses for each of those messages in there?
Yeah, you've just recorded them.
Okay.
But then, of course, what happens is the message that comes in is slightly different from the one you were expecting.
Right.
And then you just have to say, well, before I responded like this, and then something goes wrong, and that's when the API is changed.
Okay.
that the messages that come in are no longer matching the ones that I've recorded, and the responses are no longer being interpreted properly. And then,
Okay.
and then you know that you have to go and either there's a bug, or you have to go and re-record your mocks
I
against
see.
the real traffic.
And so maybe I'm dense. We have like a minute or so. I'm looking at this service, right? That's sending messages over, and these messages are being picked up by this other service that's recording them. That service will take those messages and do something with them. Generally.
Yeah, it has to have some. The service that's not included in the test that you're trying to replace with a mock has some bunch of logic and does stuff, but the mock doesn't know. It just knows what it responded last time.
Okay, I see.
And just replays the same response.
So this is really interesting. I love the idea of the mock being a test for another service, and I love the idea of you saying this code can be the same thing, which would really simplify things. Where can people go to find out more about your work?
Oh, really?
Do you have a blog or
Yeah,
something?
I have
This
a
is really
blog.
interesting.
My blog is called Coding is Like Cooking.
Code is like cooking. I love it.
And the tool I mentioned, Capture Mock, I think if you Google Capture Mock, you might find it, or Text to Test.
Fantastic. Well, this has been very enlightening for me. Thanks so much for spending some time with us, Emily. We're going to cut to a session right about now, and if not, you'll see a little bit of Slate. We'll catch you right after the break.